what we had left off on was this one. So remember here for C, we said, okay, I have a secant, I have a tangent. All of the identities are with the identity, the trig function squared. So how do I do this? Well, what we're going to do in this case, right, again, is you have to square both sides. But remember, when you start with squaring both sides, you have to then check your answers, okay? So here, square both sides, and I get cosine squared x is equal to sine squared x minus 2 sine x plus 1 is equal to 0. Okay, now, sorry, it doesn't. They're equal to each other. So now I need to change some of these identities, right? So cosine squared, right, is the only one with a cosine. So I want to insert a trig identity over there, right? So cosine squared x, we know, is 1 minus sine squared x is equal to sine squared x minus 2 sine x plus 1. So now let's move everything to the same side. The minus ones, right, they will go away, or the ones. And then, so this is 0 equal to, when I add sine squared x, 2 sine squared x minus 2 sine x. Okay? And then the way this is going to factor is I factor out a sine x. So I get 2 sine x. Yep. They'll cancel out anyway, right? So you get sine x minus 1 equal to 0, right? And then here, 2 sine x equals 0. So sine x equals 0. And that happens at 0 and pi, right? And then for the next one, sine x minus 1 is equal to 0. So x is pi over 2. Okay. Now, no, that would be negative 1. So now I need to check. Okay, because I'm checking why, because you squared both sides, okay? So x equals 0, right? And I'm going to plug it into the step before I squared. So cosine of 0 equals sine of 0 minus 1. Cosine of 0 is 1 is equal to 0 minus 1, and that clearly doesn't work, right? Okay, and then let me do x equals pi. So cosine of pi, is this equal to sine of pi minus 1? Cosine at pi is negative 1. Sine of pi is 0 minus 1. Okay, that does work, right? And then the next one is x equals pi over 2. Cosine of pi over 2, is this equal to sine of pi over 2 minus 1? Cosine of pi over 2 is 0. 1 minus 1 is also 0, so that also works. So my answers are 0 and pi over 2.
No. Pi over 2 and pi.
Oh, pi over 2 and pi. Okay, yes. Oh, okay. All right. Okay, always check, right? Okay, next page. Okay, what I have now is cosine. Now it's an inequality, okay? When it's an inequality, you know you're going to get a range of solutions, not just one answer, right? So cosine of pi over 2 minus x greater than or equal to root 3 over 2. Okay, so first of all, what's cosine of pi over 2 minus x? That's sine of x. So I just rewrite this sine of x is greater than or equal to root 3 over 2. So now I want to find all of the angles for which sine of that angle is more than root 3 over 2. Okay. So let's see. Let's go on the unit circle. Now that's a nice circle. Right? Yeah. Okay, so now is sine the y value or the x value at a point? The y value. Okay. If I'm at 0, what's sine? 0. And then as I go along the unit circle, are the values of sine increasing or decreasing? They're increasing. And then when do they reach root 3 over 2? At pi over 3. Okay? So so over here, the y value is root 3 over 2. It's like 0.866 whatever, right? Right? Okay. Now, if I keep moving along, are the y values getting bigger or smaller? Here. The y values are getting bigger until 1. Now the y values are getting smaller, but at this point in the red, right, in the second quadrant, the y values, okay, are getting smaller, but are they still bigger than root 3 over 2? Yes, they are. Until what point? 2 pi over 3. And after 2 pi over 3, what happens to the y values? Less than root 3 over 2. Less than root 3 over 2. What's the y value here? Right here. What's the y value right here? 0. And then past that, what's the y values? Negative, 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 negative. Okay, so like here, it might be, like negative 0.9, but it's still negative, less than root 3 over 2. And it's negative all the way until here. So the only region where sine was bigger than root 3 over 2 was between pi over 3 and 2 pi over 3. So my answer is from pi over 3 to 2 pi over 3. Now, we're being asked, where is sine of x greater than root 3 over 2 or equal to root 3 over 2? And because it's greater than or equal to, we also take the pi over 3 and the 2 pi over 3. So this is going to be closed brackets. Okay? If this was sine of x greater than root 3 over 2, it would have just been parentheses. Okay? Because it's all of these angles, but not pi over 3 and not 2 pi over 3. Yeah.
If the question is like, when is sine x equal to or greater than?
Okay, let me do a couple more examples and then I'll take some from you, okay? Let me do a couple more examples. Yep. Because I have some specific ones.
Do we have to memorize what each pi over 2 minus x, what each thing is? Like if it's cosine pi over 2 minus x, that is sine x.
Yeah, the cofunction identities, yes, you should know. Yep.
When we solve these, do you want us to draw the unit circle draw that circle every time and shade what you shaded in?
I mean, look, this one was a very, very basic one, okay? You have to do whatever you can do to get it right, okay? I suggest, yes, you draw it because we don't want to just like, oh, shoot, I just didn't see that part, okay? Now, suppose the question was, so let's add another one. So suppose the question was, sine of x is less than 1 over root 2. Okay? Okay, so now, here we go. Okay, we want sine of x to be less than 1 over root 2. Now, we always start from 0 and make one round around the unit circle, right? That's how it's got to be. Like, you always have to start from here and make a round around the unit circle. Okay, so where is sine 1 over root 2? At pi over 4. Okay, hang on. At pi over 4, right? Now, before that, over here, is that a region that I want?
Yeah.
Yes, this is a region that I want, right here. Okay? Now, past pi over 4, is that a region that I want? No. Where do I get 1 over root 2 again? 3 pi over 4.
Oh, wait.
3 pi over 4. Okay? So at 3 pi over 4, sine is 1 over root 2 again, right? And then right after that, sine becomes smaller than 1 over root 2. So this is a region that I want. Past the pi, is that a region that I want? Is that sine less than? Yes, because it's negative. All of this, sine is negative. I don't care what the value is. It's negative. By default, it's less than 1 over root 2. So now I have this region. Okay? And to the untrained eye, okay, that region that's shaded seems like one continuous region, but it's not, because we start with 0, go up, there is a break, and then there is another part. So if I were to describe that region starting with 0, I would say the first region is 0 to pi over 4. Okay, now here we go. Do I include the pi over 4? No. Do I include the 0?
Yeah.
Yes. So that's going to be closed. Do you see that? And then to do another region, I have to do this mark which says union. Pi over 4 to 2 pi. Do I include the pi over 4? 3 pi over 4. Do I include the 3 pi over 4? Do I include the 2 pi? Yes. Do you see that? Because at 2 pi, it's less than, like, it satisfies the thing. So now, do you see why in this case it's so necessary to draw the unit circle and not just do it in your head, right? So do this. So many times, okay, I will have students on a test say, oh, it's from 3 pi over 4 to pi over 4, right? Like that. No, that is not, like, no, you can't say that, right? That's like, that's not, no, that's like so wrong. You can't say that. That's wrong. Okay. Okay, yeah.
I don't understand why something's repeated and why something's not.
Because you have to include every single point that satisfies your inequality. So at 3 pi over 4, the value of sine is 1 over root 2. Is that included in here? No, because this is less than, not less than or equal to. Okay? But at 0, sine is 0. Is that included in this? Yes. You need to include all of the values of sine that are less than 1 over root 2. Okay? Okay, yeah.
Could you technically say that it's from 3 pi over 4 to like 9 pi over 4?
No, because it's not though, right? Because if you say, okay, because you have to start from 0, right? So this is over the interval. This is over the interval 0 to 2 pi, right? So if you go here, right, this is pi over 4, pi over 2, right? 3 pi over 4, and then pi, and so on, right? And then like 2, that's so long, but then like 2 pi is all the way here. So from 0, that's this region, and then that's this region. So do you see how there's only one way to do that, right? Okay. Okay, now, any other questions on this? Yep.
What if it was something like where is sine equal to or greater than like 3 pi halves, where it's like
3 pi over 2?
yeah, where it's like the whole thing.
I mean, then,
Just do the
I mean, if it's greater than,
Or a better question, how do you do this with cosine?
okay, so that's what you're going to do on homework. But it's the same exact thing, right? Because for cosine, if you're on the unit circle, for cosine now, cosine here is 1, right? And then it's getting smaller, right? Cosine is getting smaller and smaller to 0, right? So you kind of have to see where is cosine bigger and where is cosine smaller. Yeah.
Are we gonna be doing this with tangent?
It's possible.
Would you use secant, cosecant, cotangent?
Not this year. Okay. Now, okay, we're going to go back to what we did to this stuff here. Okay? All right, we're going to go back here. Okay? Okay, so let me talk about this stuff again, right? All right. So if I have sine of theta and it looks like this, okay? This is pi. This is pi over 2. And then here, this is 1 and this is -1, right? Now, suppose I want an equation. Suppose my equation is sine of theta is equal to 1/2, right? Well, if this is 1/2 right here, right? That's right here and right there, correct? Okay. Now, suppose now I have another equation. Now my other equation is sine of 2 theta is equal to 1/2. Okay, and now this is 2 pi, right? So now suppose that's my equation. Sine of 2 theta is equal to 1/2. How does the graph of sine of 2 theta look in reference to sine of theta? It's faster, right? It has a smaller period. So it will look like this. Right?
Yes.
And then, oh, we gotta go higher. Like this, okay? So now, how many times does the blue one hit 1/2 from 0 to 2 pi? More, in this case, 4 times, but more, okay? Right, because the frequency is higher, so it literally hits 1/2 more frequently in that region as the other one. So now, it's the same with cosine, right? So here, when we solved cosine of 2 theta equals this, and we got this answer, this is actually only half of the solutions because we need to get more of them, okay? And this is kind of like, it's like a double-edged sword doing these like before or after, right? Because it's like, when is it, better to do? So we're going to go back and for these, what do you call it? We're gonna like fine tune them, okay? All right, so let's take a look at this one. Okay, so we got what did we get? Okay, so remember how, let me start over here. Let's just remind ourselves how we solve this, right? Okay, so here I have cosine is equal to -1/2. So cosine is equal to -1/2 when the angle is equal to what? 2 pi over 3 and 4 pi over 3, correct? Okay, so now, really? That's what we're doing now? Okay. So when the angle is 2 pi over 3 and when the angle is 4 pi over 3, okay? But now, what's the general formula of this? What's the general form? it would be this plus 2 pi n, correct? And this plus 2 pi n. Okay? So now let's solve for theta. How did we solve for theta last time? Divide by 2, which is the same as multiplying by 1/2. Okay? So theta is pi over 3 plus pi n. And then what's this? 2 pi over 3 plus pi n. Okay? Okay, now we now need to generate, just like we did here, we need to generate values of theta that fit within 0 and 2 pi. All right? You see how this says to solve from 0 to 2 pi? So let's generate some that fit there. And we're going to do it for 2 of them separately. So for this one, when n is 0, what do I get? Pi over 3. Okay? When n is 1, what do I get? 4 pi over 3. When n is 2, what do I get? Is it 2 pi? Okay, so do you see how when you do plus 2 pi, now you're going past the 2 pi? So that you don't need to do anymore. These are your answers. So you have to find all of them within 2 pi. Does that make sense? So let's do it again here, huh? Yeah, on the other one as well. So when n is 0, 2 pi over 3. When n is 1, 2 pi over 3 plus pi. How much is that? 5 pi over 3. And then when n equals 2, that will go over, right? Because you will have 2 pi over 3 plus 2 pi. That will go over the 2 pi. So again, these are the two solutions. Yeah, when I ask for the 6 solutions, then yeah, you just need 6. Like there, I'm asking you for a specific number, 6. But here, I'm not giving you the number. I'm telling you find all of them until 2 pi. Okay? Right, but it was, yeah. Well, if it was,
cosine 3 theta.
yes, correct.
Would you get?
Correct.
It was like 1/2 theta.
Huh?
Like 1/2 theta.
That would be half as much.
So
Yeah.
one answer.
Yeah. Well, okay, so those change when like we're saying, for example, like if sine of theta is 1 or negative 1, because then you have a different number anyway. You know what I mean? So let's just say it this way. If it's theta over 2, okay, you will have less. If it's like 2 theta, 3 theta, 4 theta, you will have more. Okay? Okay. Okay, so why don't we like modify this one now, right? This one, look at this one. So we got here 2 pi over 3 and 4 pi over 3, right? For my answers, pi over 3 and 4 pi over 3. So how would I have written those? How would I have written those? Are those pi apart? Yeah. So I would say theta is equal to pi over 3 plus pi n. So now let's do all of them until we get to 2 pi. Okay? Okay. So when n equals 0, pi over 3. When n equals 1, 4 pi over 3. When n equals 2, 7 pi over 3. Right? What is that too much? That's too much. So that's it.
Why is it pi over 3 and not for 2 pi over 3?
Huh?
Because isn't it theta over 2? So when you multiply by 2.
Oh shoot, yes, you multiply by 2. I'm sorry. I don't know why I can't focus today. Sorry, I'm sorry. It was theta over 2. So we had to multiply this by 2. Right? So first we get 2 pi over 3. And then 2 pi over 3 plus 2 pi. How much is that?
So is that already?
Oh, that's already too high. So we just take this. Right? Half the number. Because this was supposed to be theta over 2. Right? Yep.
What determines, like, is it always going to be over the interval of 2 pi? Like, is that always your stop point?
Most of the time we go from 0 to 2 pi because it doesn't make sense to go to 3 pi. That's such a random number, you know? Yeah. Most of the time it's either to 2 pi or like over like the all real numbers.
Okay.
Yeah. Uh-huh.
Instead of doing what we did yesterday,
Yeah. Yeah, so yesterday we just found like samples, and then now we want to go and put everything together and just make sure we find all of them until 2 pi. Okay? All right. Why don't we go ahead and take a look at number 11 on the worksheet? Number 10 on the worksheet, right? That should be something at this point that you just know how to do because it was on the homework from the first chapter. It was on your test, right? How do we do this one? What do we do? Yeah.
You plug in into the graphing calculator sine of pi x plus cosine of pi x, and then on a separate line you plug in 3x.
Right.
Find the intersection.
Correct. Okay. So here you would do sine pi x plus cosine pi x for F1, and then 3x for F2, and then you get your answer, and it turns out to be how much?
Yeah, so I got 0.3.
Wait, was I? Okay. So sine pi x, right, plus cosine. So this, right? Okay, so we have this, but then I want to make it, I want to put it in radian, and I want to go window zoom, window settings from 0 to 2 pi. That's what it says. Okay, so here we go. So this is it. And then when I press tab, I put 3x.
You also like click on the X and Y hats of the number on the
Yes. Okay, so here we go. Okay, so then we're going to do menu, analyze graph, intersection. Okay, so I get 0.412 and this. So yeah, so that's why I wanted to double, because that's what I got last night and I wanted to double check. Okay, so okay, when it's pi, you have default should be in radian, especially when you have pi in there, you have to put it in degrees. Okay, so this is what I got. So right here, I'm gonna do doc B, and then it just resets everything to the usual mode. Okay, so here it says the average daily temperature in degrees Fahrenheit for a city can be modeled by this equation, where x is a function of time. X equals 1 represents January 15, x equals 2, February 15, and so on. Use a graphing calculator to estimate the temperature on January 31. That means we're going to graph this. So I graph this, and it's going to be 8.05 cosine Okay, cosine. And it's going to be pi. So let's do this. Pi over 6 x minus pi, okay, plus 66.95. Okay, so now I have pi's in here. I should be in radian. I am in radian. Okay, now we don't see anything. And so now we need to modify the axes. So let's think about this for a minute. These are the average daily temperatures, right? And so obviously it's not going to go, that's going to be on the y-axis, right? And it's not going to go from 0 to 6. Also, look at this. You have a vertical shift of 66.95. So you know, that's going to be higher than that. Okay, another way to change the axes here is if you click on this, click again, and here let's say 70, let's put 80. Okay? Okay, so look at that. Now I can see a graph. Okay? Next, if you want to move this away, you can drag it. Okay, next, x-axis. X-axis is the time. So when x equals 1, it's January 31, and so on. So then the x-axis, you know what? Let me go to menu, window zoom, window settings. I want to go from 0, 12 months in the year. Let's just go a little bit more. Let's just go to 15 so we're not like at the boundaries. Enter, and look at that. That's my graph right there. Okay, now it says use a graphing calculator to estimate the temperature on January 31, right? January 31, so when x is 1, it's January 15. When x is 2, it's February 15. So this is x equals 1.5. So really what we want here in function notation is t of 1.5. So here's how I find this. Okay, there are several ways. My favorite is menu, trace, graph trace. And when you're in trace mode, you can manually type in any point you want for x. Here, this is at 7.5, but I'm just going to type in 1.5. You see that? It says 1.5. Enter, and you get 61.3. So it's 61.3. That's 61.3 Fahrenheit. Menu, listen. Menu. Number 5 for trace. Number 1 for graph trace. Now don't press anything else. Just put in the number 1.5, enter. Okay, now. Because x equals 1 is January 15, x equals 2 is February 15, and if I want January 31, that's between 1 and 2, so 1.5. Okay, next. Approximate the number of months that the average daily temperature is greater than 70. So now I press tab, and in my F2, I type in just 70, enter. So here we go. So do you see how in this region it's greater than 70? Okay, let's trace what those values are. So menu, analyze graph, intersection here. And then I'm going to do it again for the other point. Menu, analyze graph, intersection here. So my intersections are 3.7470 and 8.2670. Okay, now let's talk about what this means. X equals 1. Let me just write that here. X equals 1 is January 15, right? And so this is the date. X equals 2, February 15. X equals 3, March 15. So when is, okay, what's 3.5? March 31st. Okay? So when I have 3.74, when is that? That's beginning of April. Okay, that's like April something, right? Okay, because 4 is April 15. So that's somewhere between April 1 and April 15. Okay, so now let's go over to 8. 8 is 8/15, correct? When is 8.26? Is that in August or September? It's end of August. So now if it says estimate the number of months, that indicates the number of full months. So from the beginning of April, we're not going to count that, so the first full month is what? April, May, June, July, and August isn't full either. So it's 3 full months: May, June, July. You see that? And this is a very AP calculus question. Okay? This, I mean, it's a very basic one, but it's okay? So now, estimate the highest temperature of the year and the month in which it occurs. And it's time already, but like menu, analyze graph, maximum, it says which graph? This graph. So here, right? 6,75. What's the 75? The highest temperature. And what's the 6? When is that? June what? June 15, precisely, right? Because that's what these are. Okay, so your homework is the next worksheet, which I'm going to give you, also 12 and 13 on this worksheet. And then the solutions to this worksheet will be posted today. Okay.
I thought that we weren't allowed